Hi students. Welcome to our code type management. In the previous lecture, I have discussed about the functional interface. There I have told you that functional interface will be that interface where we use only one abstract method, single abstract method we can use. And above that, we will use the functional interface annotations. Okay, but it was optional, not mandatory, but it was recommended. So today also we will discuss the another important Java 8 feature, which is the extended version of the functional interface, which is the predefined functional interfaces. So topics which will be covered. So what are the predefined functional interfaces? Benefits of using them. Why are predefined functional interfaces mandatory to learn? Then types of predefined functional interfaces, their examples. So first of all, predicate T, then function T comma R, then their example, then consumer, then supplier, BiPredicate, BiFunction, BiConsumer, and their examples. Then other default and static methods of predefined functional interfaces like predicate, then function, consumer, supplier, BiPredicate, BiFunction, BiConsumer. Okay. So first of all, what are the predefined functional interfaces and what are the benefits of using them? So Java 8 has provided some predefined or built-in functional interfaces to make our programming easier. Moreover, predefined functional interfaces include most commonly used methods which are available to a programmer by default. So we need not to make that methods. We can directly use them. So daily programming, many times we come across reoccurring functionalities to be developed. So for that case, we can use that predefined functional interfaces and it will save our time. So they will obviously save our development time and minimize chances of mistakes. So these are the main advantages of the predefined functional interfaces. So there are some default methods, we can use them directly. So when we use predefined functional interfaces, code becomes more readable and maintainable. Lambdas combined with functional interfaces can make the intent of the code clearer and also reduce the boilerplate code. Yesterday I have shown you that when you will use the lambda expressions. So suppose one class or one interface will extend or implement that parent interface. So for that case, you need not to extend or implement it. You can directly use the lambda and you can uh, do your logic, create your logic, or you can print something according to that using the lambda expression only without any extending. Internally, it will extend it. So why are the predefined functional interfaces mandatory to learn? So apart from the lambda expressions, we will be using predefined functional interfaces in Stream API as well. So most of the time. So if you are going to learn Stream, we would suggest you to go through once with predefined functional interfaces. Additionally, if you are using Java 8 features in your project, then obviously you are going to use them. So the Java community has started using predefined functional interfaces in new APIs. At least it becomes very crucial to have the idea of method parameters and return type of each method. So if you are not familiar with them, it will be very difficult and understand even new APIs in the language, including Java Stream API. So apart from that lambda means apart from that lambda expressions, we also use in the Stream API. So Stream API is also one important feature for Java 8, which will reduce our programming or it will uh, easy to read and easy to write also all the logics. So it will reduce the boilerplate code also using that lambda expression, using the functional interface, using the Stream API. So we need to learn this predefined functional interface as well. Then types. So first of all, I have told you the predicate. So predicate, we can use the predicate to implement some conditional checks. Wherever some condition is there, So we can use that one. So from its method signature Boolean test TT, it is clear that it takes an input parameter and returns a Boolean result, means true or false. So when you have this type of requirement to write a method, use it confidently. Okay. So whenever in your project it is required to return any Boolean result, like true or false, you need to return. For that case, you can use easily that predicate functional interface, predefined functional interface. So in this way, you can use that public interface predicate T, and return type is Boolean test T comma T. So TT. So here this T will denotes the input parameters type. Okay. So like suppose we have to write program to check if a number is a single digit or not using the lambda expression. Since it's conditional check, we will implement. Means if it will single, then we will return it true, otherwise false. So this predicate integer, here I have told you that T means T denotes the input parameter type. Okay. So predicate integer P equals to this I, just I will check that I is greater than -10 and I less than 10. Okay. So for that case, we will print P dot test. Okay, clear? So if we will see that this 9 is in between this -10 or 10, means from -9 to 9, then we can easily tell you that it is the single digit number, right? From -9, -8, -7, -6, -5, -4, -3 means in this range we have to check. And if it is okay, as 9 is in between this -10 and 10, so it will directly return that it is true. Next is function t comma r. So this is used to perform some operation and return some result. So unlike predicate, means in predicate only the input type was there, but in the function, like unlike predicate t, which returns only Boolean, but function that can return any type of value. Therefore, we can use, or we can also say that predicate is a special type of function. Okay, like predicate will return only Boolean, but function will return any kind of return type value. So we can also say that predicate is the special type of function, or it is the subset of the function which returns only Boolean values. So interface function t comma r. So r apply t. In the same way, here you have used that. So here that test one. So here we have used that test, and 9 we have checked. But here we will check the apply. So t is method input parameter, like the predicate. So t is the input parameter and r is the return type. So for example, like we have to write a program to find the length of the given string using the lambda expression. So since it taking input, performing some operation and returning result, we will implement function as below. So that input type is string and return type is integer, right? So this function f equals to s lambda, then s dot length. We will check first the length. Then it will apply, means if dot apply, I am happy now. Then it will return the length of that total string. So again, I am telling you that in predicate, we will take the input. Input can be integer or string something, but return type will always be Boolean. Okay. But for the function, the input can be anything and the return type can be also anything. So we can specify the return type as well. But in case predicate will always return the Boolean return type. Then the consumer. So consumer is used when we have to provide some input parameter perform certain operation, but don't need to return anything. Moreover, we can use consumer to consume the object and perform certain operations. Here, accept method is there. Okay. So T denotes the input parameter type. So let's assume that we have to write the program to find the length of a given string using the lambda expression. Since it's taking input, performing some operation and returning result, we will implement consumer as below. So here as well, the only one type is there, like I have told you, consumer T only, like the predicate. So like C dot accept means here consumer string C is system dot out dot println. Okay, so C dot accept, I consume data but don't return anything. So it will just consume the data. It will don't return anything. Okay, it's taking the input, performing some operation and returning result. We will implement the consumer in this way. And the supplier, it does not take any input and it will always return some object. However, we use it when we need to get some value based on some operation, like supply random numbers. Okay, supply random OTPs. Okay, means it is the supplier only. It will return the things. Consumer consumer will not return anything. Consumer will just taking the things, just consume the things. It will not return anything. And supplier will return something like any random thing, random OTPs, random numbers, random passwords. Means for the default values, like we need to return. Na? So for that case, we will use the supplier. So R is here return type. Let's assume that we have to write the program to supply 4-digit random OTPs. So we will do like supplier string OTPs. Then here the functional interface. Then we will use the lambdas. So string OTP. So for int I equals to 1, I less than equals to 4. So it will give 4 random means it will iterate for 4 times. And I plus plus. So OTP will be, I am returning like that one, OTP plus integer math dot random, means something, it's something we will get, and then we will multiply it with 10. Okay, then we will just print like OTPs dot get, OTPs dot get, OTPs dot get. Okay, you can try it. Next is BiPredicate. So this is also same as the predicate, except that it has 2 input parameters, like interface BiPredicate t comma u. So tt and uu. So here both are the parameter types. So as I have told you, for the predicate it will take one input parameter, and as by is there, by means 2. So double time of predicate means 2 times predicate. So 2 input parameter types are there. Like we have to check the sum of 2 integers is even or not by using the by predicate. So we will use that integer and integer. So one integer is I, another is j. Then we'll do the sum of these two. Okay. Then we will do the modulus of 2. If the sum of these two will 0, then we will just test that one, that it is giving the uh, true result or false result. If it is even, then it will give us true result. If it is false, then it will give a false result. So then the BiFunction. So two input will be there, like is same as the function t command. So here 2 input parameters are there. One is t, one is u. Okay, and return type is r. Okay, so t and u are method input parameters. R is the return type I have told you. Like let's assume we have to find the sum of 2 integers by using BiFunction. We will implement BiFunction as well. So like, so this is the input integer, and return type is always as well the integer. So I comma j, then we will do the sum. Here the sum of two integers is even or not. Okay, we have to find the sum of only the sum we will return. Okay, not it's even or false, and it not this one. If we will return that one, then this should be boolean return type. But now for now here we want to know about the sum of two numbers. Okay, so I is one number, j is another integer input parameter. So we will just do the sum of these two. So I plus j have written, then apply. So we have here we have used the test method for the predicate, and for the function we have used the apply, and for consumer we use the accept, and for supplier we use mainly get. Clear? Then by consumer. So for the BiConsumer, this is also same as the consumer, except that it has two input parameters like that predicate one. So it will take two parameters, means two input parameters. One is t, one is u. And for example, suppose we have to find the concatenation of two strings and print result on the console by using BiConsumer. We will implement that BiConsumer, like string, then system.out.println the sum of it. So this accept by consumer. Okay, so these are the things. So we have discussed about the but here I'm telling you that no by supplier is there. Okay, so predicate is there, function is there, consumer there, supplier is there, by predicate, by function, and by consumer is there. No by supplier. Supplier only supplier. It will supply the things like OTPs or something. It will supply. So other default and static methods of predefined functional interfaces. So however, it is just to remind from the concept of functional interfaces that in addition to a single abstract method, they can also have any number of static and default methods without violating the rules of functional interfaces. And consequently, here we will list all of them for each functional interface. So predicate T. So here a default predicate T and predicate here super T and other. So it will returns a composed predicate that represents a short circuiting logical and of this predicate and another. So what about it? Static T, predicate T means static predicate, okay, is equal. So here just in this way, and here is equal object target reference. So it will return a predicate that tests if two arguments are equal according to object dot equals in the same way. And it will also, I think, return the true or false. Then the default predicate T negate. So returns a predicate that returns the logical negation of this predicate. So if the predicate will return true through the negate, it will return the false. If it will false, then it will return the true in this way. So this is the and predicate question, then super T other. So I have told you that returns its composed predicate that represents a short circuiting logical and of this predicate and other. And in this way here or. So returns a composed predicate that represents a short circuiting logical or of this predicate and other. Next is function. So for that predicate, this default and static methods are there. So this is first one, this is second one, then default predicate negate and default predicate or predicate something super. Okay, yeah. Next is function. For the function, it's also like that default v function t comma v, and then function super r question extends v after. So it will also returns a composed function that first applies. Okay, the first thing will apply this function to its input and then applies the after function to the result. So for the first, it will apply the first function and you will get something means through that R means R is the return line, right? So first we will do that one and after that from that result you will apply the second one. Then default v function v comma r compose uh, function and super v extend t before. So this was after, this is the before. So it will returns a composed function that first applies and after that and before the function to its input and then applies this function to the result. So first of all it will apply means that one. So from that what you will get, then this function will apply for the on that result. This is the before after case. Then the static function identity. So it will return a function that always returns its input argument. After that, consumer. So that default consumer t and then, and here also after is there, right? So it will return a composed consumer that performs then in sequence this operation followed by the after operation. Then supply, there are no default or static methods in this interface. So I have told you like no buy supplier is also there and also no default and static methods are also there. So one question may come like there are default and static methods are there, right, for the functional interfaces. So for which functional interface there are no default or static methods? So the answer will be supplier. Now for the BiPredicate. So here also default BiPredicate t comma u and BiPredicate then super t then super u another. So it will also returns a composed predicate. Okay, that represents a short circuiting logical and as and is there uh, of this predicate and other. Then negate. So here it will return that represents the logical negation of the predicate and here or is there. So it will do as same but here or. Then BiFunction. So here also and then is there and after. And for the BiConsumer also and then is there after is there. Okay, so it will also return a composed BiConsumer that performs in sequence this operation followed by the after operation. So moreover, if you will still want to learn, then I am also uh, suggest that please visit the Oracle documentation. So there you will get the real-time examples as well. Okay, so for now, I am also discussing about some frequently asked questions. So can I create my own custom functional interfaces? Yeah, obviously you can create custom functional interfaces by defining an interface with a single abstract method to indicate that it is aimed to be functional interface. You can annotate it with functional interface, but it's not mandatory. It's optional, but it's recommended. So after that, can a predefined functional interface have additional non-abstract methods? Obviously, predefined functional interface can have additional non-abstract methods like default or static methods without violating the functional interface contract. And these additional methods provide utility and convenience, but do not affect the single abstract method requirement. What are some alternatives to predefined functional interfaces in Java? So alternative to predefined functional interfaces include using regular interfaces with custom single abstract methods, anonymous inner classes, and method references to create functional behavior in Java. So we can use the custom single abstract methods, anonymous inner classes, and method references to create the functional behavior in Java. So can I use the predefined functional interfaces to represent the functions with more than one argument? Yes, you can use the predefined functional interfaces like BiFunction. BiFunction is there, right? Then uh, uh, yeah, more than one argument is there, right? BiFunction. two arguments. You can also create your custom functional interfaces for functions with multiple arguments. So again, I'm telling you that predicate for when you want to return some Boolean things like true or false, you can use easily that predicate interface for the function. Like you will taking one input and just returning some result. You will use the function, and for the consumer, like it will consume your data or something, and according to that, it will return the result only. And supplier just it will supply some random things like random number of digits, random OTPs, random passwords. So for that you can easily use the supplier. And also BiPredicate is there, BiFunction is there, and BiConsumer is there, but there are no BiSupplier or something. Okay, supplier is only thing, and it has also no default and static methods. For the other interfaces it will have some default and static methods. Okay, so that's for all now. So again, we will meet in the next lecture. Thanks. Till then, keep watching and just keep practicing. You can ask some other questions as well if anything will come in your mind. Okay, so that's for all.